Hello, everybody. I'm very pleased to welcome our folks from Synapse with us here today. Teja Chatty is going to kick us off, and she co-leads the Sustainable Design Group at the Synapse Product Development. She has a background in mechanical engineering and supports sustainable decision-making during product development. Will Harrison is a mechanical engineer leading the Industrial Climate Tech Group at Synapse Product Development. He's been working on sustainable design practices since 2019 at Synapse, building more sustainable hardware products for clients. Welcome, both of you. Take it away.
Hi, thanks so much for having us, and thanks to everyone for joining on the use of lifecycle assessment, or LCA, in product development. Yeah, so we're going to be sharing the processes we've developed for using lifecycle assessment, LCA, in our product development process at Synapse, and what we've learned from these first few years of implementing this strategy with our clients. We're going to discuss the opportunities there are for using LCA in the design process, as well as some of the limitations we have encountered and the challenges we've found. We'll finish by going through some case studies before we have some time for Q&A, as Holly said. But yeah, feel free to throw your questions in as we go. As you see something that triggers a question, put it into the Q&A section, and we'll get to these when we can. I'm looking forward to having a discussion as well as just presenting what we found. I think that's the goal of today, is to really stimulate some discussion here about how we best use LCA in the product development process. I'll give a very brief introduction to Synapse Product Development. This is where both Teja and I work. We're a product development consultancy developing hardware products for our clients. Everything from wearables and smart shoes, as you can see here, all the way up to industrial scale carbon capture systems. Our strength really lies in our integrated multidisciplinary teams, pulling together electrical, mechanical, software, firmware, and manufacturing engineers into one team to quickly take a project from concept, an idea, to reality, and produced in the thousands and being delivered to consumers worldwide. If we jump to the next slide, we just quickly mention that we really aim to make a positive impact on the planet. We prioritize work that has a positive impact on the planet, particularly in our climate tech work. And we also endeavor to make sure that any project or product we work on has been designed sustainably, minimizing any of the negative impacts that it may have on the planet. This is where our sustainable product development process is really key to this. We want to make sure that we're using data and our design process to ensure that we're mitigating any of the negative impacts the products we develop and design have on the planet. So again, we move forward, we work across the product development timeline, everything from generating early concepts and ideas when a customer comes to us with a problem but no known solution, all the way up to getting products manufactured at high volume and transferring them to manufacturing in factories around the world. We take an iterative approach to development. We focus on addressing the highest risk areas of a product early to successfully bring novel products to market with really high confidence in their performance. You'll see this iterative approach throughout this presentation as it's really core to how we work. You can see it's on this next slide where I'm going to go into it a little further. We really focus on having this iterative loop as we work through our design process. It's never a linear process of just you start and you progress along and you never loop through. We want to make sure that we are really iterating on our designs as we go to come out with the optimum product. So our design approach, once we've defined the product and the problem it's solving, is to iteratively work through what we identify as the highest risk areas. We identify these either through a risk assessment or just through looking at the most challenging parts of the design. We then develop solutions to these and then test these designs or prototypes to validate that these solutions really truly address the risks and give us the performance we want. So that's how we do it for any general product, and that's our product development process. But when it comes to sustainable design, we want to do the same, but with the environmental impacts as the risks or the parts we're considering in our iterative process. This is where LCA is core. It is the heart of the process. as it is the tool we use to identify these risks, identify these big environmental impact areas of a design. We can then take these identified risks or the biggest environmental impact areas and focus our design innovation to reduce or mitigate this impact. We then test these concepts, test these designs to ensure they meet all the other product requirements they need to meet, as well as testing and validating that the changes we've made actually do reduce the environmental impact. This cycle can then repeat as we use the results of this updated LCA that's hopefully shown that the innovation we've made and the design changes we've made has reduced the environmental impact. And then we can see what the next highest area of impact is, or the next component or part of the product that's causing a big environmental impact is. And then in the next iteration and design iteration, we can then rerun this and see whether we can reduce the impact even further. We want to be able to really run through and find the best solutions and continuously iterate, continuously improve the design. Sometimes we don't have time to do a huge number of iterations. Sometimes it's only one or two, but this is how we do our process. So for a quick example, for a wearable product, for example, something we used to do at Synapse a lot, maybe we don't do very much anymore, but we might run an LCA on the design of our first prototype and see that the biggest contributor to the environmental impact of the product is from the main printed circuit board assembly and the manufacturing and production of this. As we refine our design, we're going to look for ways to reduce this impact. So we've identified the risk, and then the innovation is going to be how we reduce that impact. It may be by reducing the circuit board size, selecting lower impact components, and working with component vendors who use more renewable energy in their fabrication processes or lower impact fabrication processes. We then want to validate that these design choices have both reduced the environmental impact of the design by repeating the LCA with this new design, and then validate that this design iteration still achieves the product performance that we're aiming for. So this really is the core of our process and how LCA allows us to quantify and identify the biggest environmental impact areas of a design early on in the development process. So if we jump to the next slide, I've said that LCA gives us the data we need to identify these environmental impact risks of a design. But then I need to talk to how we innovate, how we develop solutions to reduce the impact and reduce these identified impacts. One tool we use is whole system mapping, which is what is illustrated here. This is a tool that we use to identify potential solutions to these environmental impacts identified in an LCA. These maps illustrate the full product lifecycle, mapping the flow of materials, money, data, and energy from material extraction, from producing everything that's going to be part of the product, all the way through to the end of life of the product. We then add in the environmental impact hotspots identified from LCA to focus our innovation efforts, as this really allows us to look at which areas of the full big product ecosystem are contributing the most to the environmental impacts. So for example, here, starting on the left, we have the factories into which either their materials are being extracted and subcomponents are being produced. These then feed into the factory where everything's being assembled and integrated. And then from there, it's being distributed through various different distribution platforms, online, in store, to the user. And then from the user, it is going to landfill at the end of life. So this is not an ideal situation. And this is what we'd use as sort of a baseline system map of an existing system. Maybe it's the previous generation product or just what a client is coming to us with their planned ecosystem. We would then use this in brainstorming sessions to identify ways to reduce environmental impacts, and particularly those we've already highlighted using lifecycle assessment. So these sessions, we look to find innovative solutions. For example, we might be looking at how we could remove certain nodes of the system. So for example, in this one, you can see that we have a significant climate change impact from one of the factories that's providing subcomponents. Maybe we try to remove that system. Either we remove that component from the product, or we find an alternative supplier that can help reduce that impact. Sometimes we try to introduce new material flows. So we see a big problem at the end with toxic waste that's going to landfill. This may be a place where we try and introduce some circular material flows going through recyclers or repair systems that are going to keep these products in cycle, in use, extend their life, and hopefully reduce the overall environmental impact as we also are managing this waste more effectively. So this is simply a tool that we use to structure our design process and visualize the impacts, and particularly early on when we want to look at the full big ecosystem that goes around the product, not just focused on the detailed design of an individual component. Before we have a detailed design or like product definitions that we can use to provide the inputs to an LCA. Typically, you're going to need the materials, the masses, all the processes, and everything that you use as an input to an LCA. But we're really wanting to make decisions early on in the product development process. So this beautiful chart on the right is sort of showing how as you go through the development process, the later on you get, the harder it is to change things. There's bigger cost of change. And you might have locked in things early on in a decision you took without a lot of data, and that may have locked in a big amount of environmental impact or harm into your product design. So we want to be able to make these decisions early on in the development process before you have a detailed design. With data, we want to be informed here and make decisions, and this is where we want to use LCA. So it's challenging. The typical tools require detailed data, detailed designs. But at this stage, we won't have that. You may just have a sketch or a number of sketches for different concepts. And this is where we really have lent into using our engineering judgment and engineering knowledge, where we can run quick and lightweight LCAs. So we're going to use our experience and judgment to be able to estimate, okay, maybe there'll be about 300 grams of plastic in this design and this amount in this. And then this one will need this sort of area of circuit board, and we use this amount of energy. We'll also include our error bars on these as inputs to the lifecycle assessment to ensure that that is propagated through to uncertainty in our results. This allows us to do very quick, lightweight LCAs that compare different concepts and see just like how a concept is what looks like it's going to have the biggest environmental impact. We'll talk more about its uncertainty later on in the slides. That's definitely a big thing we have to consider at this stage because those uncertainties are so large that making decisions can be challenging. But it's much better to have some data at this point, knowing the level of uncertainty, to be able to make decisions when you have so much flexibility. You haven't locked anything in, you haven't chosen a certain path yet. And if you can identify a different concept that has a much lower environmental impact or is much more sustainable, now's the time to do it when it's going to cost you much less and you have the bigger flexibility. So as we iterate, we're going to focus on refining and reducing the uncertainty around factors that we've seen are like potentially the biggest impact area. So going back to that wearable example, it's probably going to be the electronics. So we're going to focus on, as we refine our design, getting more precise about which specific components are used, what exactly is the area of the circuit board we're using, and that helps reduce those uncertainties. And also, we'll be focusing our efforts on this area because I imagine even with a large uncertainty on the results, we'll have seen that's probably one of the biggest environmental impact areas. And it lets us focus early on can we do it with a different solution? Is there something we can use in parallel to reduce how much electronics we need in this? Could we put most of the functionality onto the phone that the user's carrying with them? Can we do something drastically different to the concept that's going to help us address the components or the part of the product that we have identified as causing the biggest environmental impact? So again, as we look at more detailed designs and concepts, on the next slide, we'll show how We sort of increase that detail and rigor and precision of the LCAs we're performing, and that lets us make increasingly more informed decisions and more precise decisions. As I said earlier on, we may have been using very high-level estimates of inputs to an LCA model, or even just simple spreadsheet model tools to compare concepts on a single score. As we move through the design process and we get more detailed and refined designs, we can add more precision to the inputs to an LCA and start using analysis tools such as MATTR-PD or SEMA Pro to produce results across a range of impact factors, and not just be comparing on a single score, but getting a bit more nuanced in how we're considering the environmental impact of a product. So this sort of slide just illustrates often we're comparing different concepts as we make decisions on our path forward. And environmental impact will certainly be one of the factors we use when we're making decisions on which concept we choose to take forward, but it won't be the only concept. Sometimes when we have lots of different stakeholders in the room, it can be hard to make sure that sustainability gets considered. But having LCA data and having quantifiable metrics on the environmental impact of a product really helps sustainability get considered equally as a factor in decision-making when you're choosing concepts going forward. So LCA has really been helpful in allowing us to make better decisions as we move through the design process and choosing concepts to move forward with.
Alrighty. So I can pick back up over here. As Will pointed out, running lifecycle assessments during product development is challenging because we do not have all of the data we need to run a detailed assessment. So what we're often working with are initial sets of data that's based on prototyping or existing products on the market, or estimates based on our best engineering guesses. And often this leads to large uncertainty in the assessment that we try to account for when we're running these LCAs early in the design process. Sometimes, in the example that Will was giving us, like a variable with electronics, often the electronic components have the biggest impact and this we know based on some of our experience running similar lifecycle assessments. In that case, what we try to do is focus on trying to hone in on the data required to quantify that particular sub-assembly or subcomponent in more detail, and then using that to reduce the uncertainty in those high impact parts. And that allows us also to save time when doing these assessments iteratively, because we're often on a very fast-paced schedule during product development. However, when we do get to a point where we realize that the uncertainties are still limiting our ability to make decisions, we lean on other approaches, such as trying to validate our assumptions. In this case, we may consider picking different material alternatives, for example, if it's the material choice that's leading to the uncertainty, and then run a sensitivity analysis to then try to pick materials that are closest and contribute to the least uncertainty in the assessment itself. Often we also have to reach out to many of the client's suppliers, trying to get more primary data from them on the specific materials that are going into certain components, or trying to understand where exactly they're sourcing their materials from. So we can try to specify our assumptions as much as possible. Another piece that we try to work on is doing additional due diligence when selecting material alternatives. So sometimes we work with novel materials that may not exist in lifecycle assessment databases that we can select from. So then we work to either reach out to those suppliers to identify what the impacts of that specific material are, or we work to identify what best alternative there is in the database that both is close in the material properties as well as the environmental impacts. And then use that to try and specify our assessment a little bit further. Often, because this approach is very iterative, we wait to progress in the development process to fill in some of these gaps as we're doing our product development. And this has been sort of the best compromise we've found to be able to run quick lifecycle assessments during a product development process and to provide this information as early as possible to our engineers who are then relying on this input to make the best possible decisions that are both feasible engineering-wise, but are also the lowest impact from a sustainability standpoint. Something I also wanted to point out is besides our design concurrent lifecycle assessment approach that we use in product development, there are a number of different topics that we have started to build capabilities in, and this is often driven by what the market is looking for and where the biggest needs are arising. Something we've been trying to do is incorporate principles of circular design into our product development. Often this looks like making sure that the products that we're putting out into the world are capable of fitting into a circular supply chain. So this could be designing products for easy disassembly. We have specific tools that help us assess ease of disassembly, like disassembly mapping. We also try to understand what the recyclability and ease of repair is of the products that we're designing, so that then these high value components that are also high impact can be easily taken apart and remanufactured or reused in future iterations of either the same product or a different product. Another question that we often get asked is to try and quantify the business value of our sustainability measures or recommendations. And this comes down to trying to quantify both cost and environmental impact simultaneously during product development to show that oftentimes these requirements trend together. Sustainability measures such as trying to lightweight a product, for example, to reduce the amount of material, or using circularity to try to recover value instead of letting the whole product go to landfill, often has positive business impacts. And I think more and more of our clients are realizing the value of implementing sustainability when putting products out into the market. There are also non-quantifiable benefits like brand value, customer demand, as more and more consumers become aware of climate change and want to make sustainable decisions. We've also recently worked with clients to help create end-of-life management networks. So helping them identify repair partners, recycling partners, remanufacturing partners, or working with them on understanding what reverse logistics is possible. Another area that keeps coming up in our work is around regulations and reporting. Regulations and reporting requirements have driven a lot of our clients to accelerate how much life cycle assessment they do, and wanting to be able to do these assessments at scale. Often these requirements also drive them to improve their supply chain transparency and traceability, because they really need to understand where their parts are being manufactured and then where the materials for those parts are coming from. Often this is an example of where this would be valuable is ensuring that they're within forced labor protection compliance Another piece that this data collection supports is digital product passports. If you've heard of the EU's eco-design sustainability regulations, they're starting to require digital product passports that then make allow consumers and the government to understand what the environmental impacts of your product are, but also what where the parts are coming from, where the materials for those parts are coming from, and whether everything is in compliance with relevant regulations. Finally, another big need we've noticed in the market is around sustainability data management. So this has to do with what I said earlier about running assessments at scale. Often companies store a lot of this data that's sourced from suppliers in various platforms or Excel sheets often that are not really tailored to be automated to run quick life cycle assessments. So we've worked on cases where we've had to help them centralize their sustainability data, centralize their supplier information, and then help that data flow in a way that they can run life cycle assessments at scale and then also report on them in a reasonable amount of time. So these are some new areas that are related to our design concurrent life cycle assessment, but we've had to expand our skill set to work on. All right. Now we're going to go into some case studies of what we've recently been working on and some stories around how we've applied design concurrent lifecycle assessment. This is a really interesting project we just finished working on, where we're helping this client design a next generation electronic fragrance dispenser. And as you can imagine, there is a lot of electronics, there is a battery, and these components we found had the greatest impact. And we were asked to compare the impacts of this device against refillable and non-refillable glass dispensers for fine fragrances. So we ran an assessment trying to make those comparisons and found that while the electronics significantly drive the impacts high for the atomic dispenser, the impacts for non-refillable glass dispensers, where the glass is just discarded after every use, is still pretty significant. So we help them consider circular business models, both for their glass dispenser business, but also for the electronic dispensers, where they can try to recover value from the printed circuit board, from the battery, or from the glass bottles, to make sure that they're reducing their impact and reducing how much material ends up in landfill. Another case study is a project we worked on with a home composting system client. And in this case, for the first generation of the product, we were actually involved in the design and development of the device itself. And then in the second generation, we only engaged with them on the life cycle assessment. What you see here is a comparison of the first generation design against second generation design to see where those environmental impacts were coming from, what caused this increase in environmental impacts moving from the first generation to the second generation, and then making recommendations on how they might reduce their impacts going forward in the future. I'll pass it back to Will to cover the rest of the case studies.
Yeah, thanks, Teja. So yeah, the next one we're talking about is basically smart health device for pets. It's a smart scale. And for this, we ran an LCA later in the design process than we would have liked to, which didn't leave us much room for iteration. So this is one way that our case studies sort of show sometimes the reality doesn't always match our ideal process, where we may not have been involved early on and we get brought in later, but we still try and include our iterative process and run an assessment to highlight the biggest impact areas. So as with many consumer electronic devices, we found the electronics are the largest contributor to environmental impact of the product. With a very rapid design cycle they were working on and significant resistance to change of the initial design, it was really challenging to implement design changes to reduce that impact. Thankfully, one of the biggest opportunities of reducing that actual printed circuit board size and with more efficient layout, more efficient design, also aligned with cost savings. So that really allowed us to push that change through in a design cycle where we were otherwise very constrained. We managed to get multiple stakeholders on board, both our own desire to reduce the impact of the product and also some of the more business-focused stakeholders on the client side could see the advantage of reducing costs and pushing that through. We also leveraged some of their existing returns network and repair facilities to implement some circular business model solutions where we could reuse some of the largest plastic components that had a pretty big impact and some of the electronics that could be put into refurbished devices, extending that life of some of those really big impact components. So this is where we use that sort of whole system map, and the top right image there shows the whole system map, and highlighted in yellow are the new material flows we added to try and increase the use of recycled or refurbished materials. The bottom right here also shows a disassembly map, just showing how we assessed the assembly and disassembly of the product and design it to be repairable and allow that circular business model to work. So the next device is a little different. This is a ticketing and access control piece of hardware for a stadium. And it's a sort of access control stanchion. So this is sort of sitting at sort of chest high, and it's something you interact with as you're going into and out of the stadium. Due to this, it's pretty robust to the environmental conditions it's got to see and just general rough handling it's going to get as people brush by it, bump into it. So it's pretty heavy. Running an LCA on this design just highlighted how much that large mass of materials making up that base plate and the base cover were really contributing to the overall environmental impact of the product. This allowed us to really focus our efforts as we move forward on finding ways to reduce that. So that was our first run of sort of 5 prototypes. And we ran this assessment okay, they're really contributing a lot for just a couple of components. So we worked closely with our manufacturing engineers and suppliers to find alternative suppliers, as well as trying to refine our design. So this is where we found a really great supplier that's using 100% recycled aluminum for their casting processes, massively reducing that impact from the embodied energy required to extract the material. And they're also based in a geography within the US that was using a very high proportion of renewable energy, further reducing the environmental impact of this manufacturing process. So this was a big win for us, finding a good partner and being able to reduce that impact as we move forward. And then finally, in our final case study of the presentation today is from a smart footwear product. Again, as with many of our consumer electronics products, the electronics themselves are the biggest contributors to environmental impact. Thankfully, with this company that was large enough, we could work with vendors to really push to find lower impact components and push these vendors to provide data to allow us to get more precise data on each individual component instead of an industry average or a close approximation from an available LCA database. So by doing this and working with these integrated circuit fabricators, we could use this as a criterion decision-making on which chips are we going to use on this circuit board, not just on their performance and features, but also we can include their carbon footprint or their embodied energy in fabricating these chips. There were also some other opportunities in this product that we found that aligned with cost savings. So again, easy to push through, especially in transportation of products from their manufacturing locations to the consumers. They had really been transporting them with like low packing densities, so they were becoming volume limited rather than weight limited in shipping containers, which makes it pretty inefficient for both cost and the environmental impact of shipping. So that was a pretty simple change to make to come up with a more efficient packing and packaging system, and helps them reduce both their cost and the environmental impact of shipping things around the world. So, as I said, many of these case studies included only one LCA iteration, only one iteration of our lifecycle assessment, as we were often brought in later in the design process, or simply these projects started before we were doing our sustainable design process and we were developing our capabilities here. In the future, I'm really hoping we can develop even bigger impacts as we continue to integrate lifecycle assessment into our design process from the start. I see we've got some questions, so I'd love to jump in and answer some of those, and just
Yes.
hear any other thoughts you have.
Thank you. And our Lisa Lauren will happily ask those questions for you. Thank you.
Thank you, Will and Teja. It was a great presentation. We're really pleased to have Synapse as our partners. They support us in a lot of ways, and we really appreciate that. We have a lot of questions. I'm going to not go through them in order. I'm going to try and do them a little bit in an order that makes sense sequentially. So the first question I want to ask you is, how do you quantify the uncertainty when you're actually doing that LCA to begin with?
This is a good one. And I think we probably can do a lot more to improve how we quantify that uncertainty. Certainly in the early stages, we include the uncertainty into like the inputs to what we're doing. So we can say, all right, well, we have 27 grams of plastic going into this wearable, but probably plus or minus, honestly, 50% at this point. And then we can propagate that through, but also we know we have to add all the other uncertainties that are, is this database entry a perfect match for the actual materials that's being used? That database entry itself has its own uncertainty included on it. So we do try to quantify both the inputs and then include uncertainty elsewhere. The hardest part I find, honestly, is quantifying uncertainty of, is a database entry that we're using a good match for the actual part or product we're analyzing. And that is where it sort of becomes good engineering judgment and comparing alternatives and seeing, and then sometimes it's simply a case of comparing the alternative concepts and checking like, this isn't just a feature of the database entries we've used, this is sort of you have to go a little deeper into the data to see that, all right, these different concepts actually have a significantly different impact, or sometimes they have overlapping uncertainty and they're not statistically significantly different. And then we have to make decisions on other factors, and some of them may be, okay, we want to look at different impact factors, not just carbon footprint, which is often the one we go to by default as the one our customers are most often asking about, or just what we think has the bigger opportunity to reduce its impact going forward, and has better opportunities for us to improve our design. I know, Teja, you may have a better answer than I do that.
No, I think you definitely covered all of our different ways of trying to quantify uncertainty, given the time crunch that we're often on. So we start by working with ranges of values with our inputs and then try to propagate that through. And then we use sensitivity analysis when we're trying to figure out how much the impacts vary when we're looking at different alternatives to be considered.
The next question follows on from this, and I'm going to interpret it a little bit. And I hope that Carly, if you disagree with how I've interpreted it, you will type your question again. It's how do you balance the level of certainty at those early stages? And to me, what that means is, how do you balance the uncertainty that you have with the uncertainty of your result? Is the is the uncertainty affecting where your hotspots are, or is it really something different? And how do you think about that?
Yeah, that's a really interesting question. I think often in the small consumer electronics space that we work in, the impacts of the electronic components overshadow the impacts of any of the other components in the device itself. So even with big levels of uncertainty, our electronics are often the go-to target to try to reduce our impacts. Sometimes with larger devices like the stanchion that Will showed, other materials like aluminum tend to overshadow. So we often see that most of the impacts come from one or two different sources that then we try to target and not get bogged down by trying to specify every single component.
Great, thank you. Next question is, do you assign LCA experts to the project early in the process, or do the product developers actually do their own assessment?
So we try to have the product developers and the engineers do the assessments, but we have provided training, and Teja has done a lot of this training and upskilling of our engineers to give them the capabilities to do this. We do also have a sort of core, smaller group of mixture of engineers, LCA practitioners who often get pulled in to do reviews, and like essentially provide mentoring to our product developers as they go through and are doing the LCA to like check assumptions, check the inputs are correct and that the results are being interpreted reasonably. So yeah, it's a mixture. We do try and provide that sort of expert review support, but we're really trying to empower our engineers to be able to do this themselves, to really just make it part of the process and mean that we can scale. So we're not limited by, we have 10 different projects going on, but we only have 2 LCA experts. We might get spread a little thin.
Yeah, that makes sense. And I think the next question follows right from that, which is, what LCA software do you use and why?
Yeah,
Yeah,
that's
so go ahead, Teja. I think you should take this one.
no, that's a great question. I think it really depends on at what stage in the design process we are, how much data we have available, and what level of detail the client is expecting in the results. Often, if it is for our own internal decision making, we rely on spreadsheet-based templates that we've developed that pull from various databases. And that gives us the most flexibility in terms of setting uncertainty levels or making comparisons between different materials. So we try to do those early assessments on spreadsheets. And then we progress that into tools like SEMA Pro that we then use for more detailed assessments. We recently got our license to Matter PD, which is a tool that Earthshift offers. And we're starting to train up our folks to use Matter PD in somewhere between that very early stage and the more detailed assessments.
Thank you. And Teja, we have to acknowledge here that you were very instrumental, and so was Synapse, in the development of Matter PD. And thank you for that. How do you define the different stages of product development and scale? Are all early LCAs based on a techno-economic analysis?
Ooh,
You want to
so
go
two
for it, Will?
questions there. I'll answer the first part of the question on defining the different stages of product development and scale. So I think with that, we previously had a pretty linear, very structured sort of stage gate, design gate process where you'd have your sort of early scale alpha prototype, then you would have your maybe a beta prototype, and then you have your engineering verification, your design verification, your production verification, and you'd have all of these steps. And it was a very rigid process. But at each you were trying to kind of do everything. Whereas we've sort of adjusted our approach to really focus on how we can address the biggest risk areas. So it may be someone comes to us and they are wanting to do a new wearable and they need to they want to measure blood pressure using some new technology, and that's the thing that matters. And that's what we'd focus on up front. That's what we'd spend the first iteration doing. The prototype we produce probably look nothing like the final product and may only have that one feature and none of the other features, because we're not worried about the rest of that. We can add that in later. We try and do the sort of key de-risking early. So we've sort of moved away from the different stages of product development as much as we can and just try to do this sort of risk reduction process. It still means we do have stages with hardware. We're doing builds and then we're testing and then we're doing another prototype build. So sometimes it does fall into some of the more traditional stages of product development. But yeah, that's how we try and do it. And I might hand over to Teja to ask about whether all our early LCAs are based on a techno-economic assessment.
So that's an interesting question. We typically do techno-economic assessments when they're specifically asked for by the client. Otherwise, we have our what we call a new product introduction team, or our supply chain team, that runs a COGS assessment, a cost of goods sold assessment, to try and quantify the cost of the product as it moves through product development, and then start to get quotes from suppliers. So now what we've tried to do is create a template where we can track changes to cost and environmental impact simultaneously. So that's kind of how we approach the cost question.
Wow, that's really interesting. The next question actually has to do with an estimate of a net present value or value proposition for the strategies. And it sounds like you are tracking that through the process, which is really interesting. Yeah, that's really cool.
Yeah, we have a whole team of what we call new product introduction engineers, or NPI engineers, who are really focused on making sure, like, the engineers who are deep in the details of the technology are also considering what bringing that product to market is going to look like in terms of cost of manufacturing, distribution, maintenance, and all of these parts of the business model that really need to be considered. So we often have, as they said, cost models running in parallel with everything else that are also refined through our process as uncertainty gets reduced on. It could be, right, we know it's going to be a steel part, and then we know exactly where it's going to get made, and now we know exactly what the design is. So that uncertainty also narrows down.
Right.
And we can sort of model what the business case and cost and value will be.
Yeah. One of our attendees asks for more information about allocation. Do you want to share just in general how you approach allocation?
That's a good question. I think when we are doing our life cycle assessment early on, we try to stick to a default method of allocation where the impacts of the parts are calculated based on like the specific unit. I think now that we're starting to move into more circular business models and guiding our clients there, that is something that we're working to understand, is how do we effectively quantify the environmental impacts of these more circular supply chains. I think it is a work in progress and something that we're trying to learn how to do better.
Yeah, and that kind of leads into the next question, which again, I'm going to try and interpret and may not do it correctly, but looking at your design for reuse, design for recycling, design for reuse and disassembly, do you focus more on reusing components or chunks rather than recycling?
Yeah, that is a Yeah, no, that's a great question. I think we start by making sure that the components can be taken apart effectively and there's opportunity for reuse, which is where most of the value is preserved. I think recycling is kind of the last alternative before landfill. So we start by making sure our products are easy to disassemble, easy to repair, and easy to then hopefully remanufacture where feasible, and then eventually recycling. What do you think, Will?
Yeah, I think that's exactly right. It's sort of the people have seen the butterfly diagram of the sort of circular economy from the Ellen MacArthur Foundation. It's trying to take those smaller loops first and prioritizing those smaller loops that also cost less and are more efficient, where you are just repairing a device because we've made it easy to repair and easy to access parts. And that part that we know has a limited lifetime is one that you can access easily and swap in. Or we designed it in a modular way so that as technologies develop over time and we know something's going to become outdated, particularly with electronics going forward, that then something can be swapped in the future to keep it up to date, but mean that you can keep using 90% of the device, and not throw the whole thing away because you want to update one part of it.
I think
It
that
becomes quite complex to sort of model in an LCA when you end up. It can become hard to sometimes quantify all of that. We have to make assumptions over percentages of products that last a certain lifetime and take certain flows. But also, a lot of those principles that we apply for like this circular design are kind of good practice regardless. We can sort of implement them in most areas, unless there's some like huge trade-off of, oh, to make this particular part modular or accessible, suddenly we're adding 12 other parts that are increasing the impact. But yeah, that's
yeah. Or if once if it's not recycled in most cases or reused in most cases, that the impact is much greater. And I think that kind of leads into the next question of modeling, which is how do you model recycled materials, especially when you use them, right? You might be using a recycled material at the beginning of life, and then you may be recycling at end of life.
Yeah. So one thing that has helped us with trying to model the impacts of using recycled content is databases now have recycled materials more and more. So we're able to quantify the impact reduction, for example, in the stanchion case where switching from virgin aluminum to recycled aluminum, we were able to quantify that difference. And then at the end of life, there's some impact associated with the recycling process itself. And really, it then depends on whether the client considers that to be within their scope for the assessment or not. So they do, so they see a benefit when they use recycled content up front, but then there's some additional cost to the recycling process itself that then, may or may not be part of the scope for the assessment.
I'm going to get geeky here on you and ask if you use the cutoff database in EcoInvent or if you use one of the other databases.
We use EcoInvent most of the time. Is that right?
we use cutoff.
You use
Yeah,
cutoff.
we use
Okay.
the cutoff. Yeah.
Yeah. So you're using the cutoff method. You're not using the CFF method, and so that'll help the questioner.
Yeah.
Awesome. Let's see. How do you convince vendors and suppliers to give you primary data?
That is a tricky piece of the puzzle. Often our clients have established relationships with their preferred vendors for certain parts. So then we rely on that relationship to get the primary data. Sometimes clients come to us with no idea of who the vendor for those parts is going to be, in which case our NPI team has to quote a number of different vendors to decide who would be the best pick for the client. I think with increasing regulation and reporting requirements around product carbon footprints, vendors are starting to have to quantify what their impacts are. And I think we're relying on that trend because a lot of these vendors are now publishing that data.
Yeah. For us, it often falls on, does our client have enough leverage so that they can push their vendors to provide that data? Are they a big enough customer of theirs that if they say, you must provide this to us to continue to be a vendor of ours, then that helps for sure. And it helps when you have a big company backing you to do that. That can be harder otherwise. But sometimes when you're also asking for quotes, you can include in your like request for proposal or request for quote a line or two in there about please include these pieces of primary data. It is hard. It is hard though, and particularly if you're a smaller company or smaller fish trying to do this, you can't always get that data from people.
Yeah. I'm going to ask another question that's two questions in one, and then I'm going to add a third one because I think they all go together. What kind of data do you think would be helpful for you to have when designing across different product types? Do you think the only way is to have the individual data from the supplier or client each time you start a new project, or do you see other alternatives? And I think the other question is, what data do you wish you had was readily more available?
So I think we would love to have data that is more easily accessible when we know, like, we have specific grades of material we're using or specific components we're using. And we have to look at data sheets for all of these anyway, because we're looking at their properties or their features. I would love it if each of those had some form of LCA database entry in their data sheet that we could pull in. And I don't think that's the only way, because we also know we can take industry averages and compare different design concepts where, yeah, there's more uncertainty, but you can still see potentially big differences just in you're taking a completely different approach. I would love it, particularly for our electrical engineering team would love it if they could have data associated with all the electrical components, because they already have a database that has all the footprints and everything that goes into a printed circuit board design, and it automatically creates a bill of materials for them and does a lot of other things as they do the design. And they would love to automate essentially an LCA of some level of at least the materials and manufacturing going into their printed circuit board assembly design. And our team are trying to work out if they can automate that with our database system, which I think they could, but we then need to be able to get the primary data. Otherwise, we're going to be using estimates again and inputting that. So that's sort of really what we'd love to do. I hope I answered that question effectively there.
I hope so too. It was a complicated question. The last question I'll answer, Matter-PD is commercially available, and it uses EcoInvent cutoff also. I had a couple of questions. If you all want to stay on for a little bit longer, I understand if people need to drop off. But my two questions are, the first one is, how much does the client participate in the impact reduction process? Do you, when you're going through, you've drawn your map, do you go back to the client at that point, or is that all done internally by Synapse?
It really depends on how much the client is sustainability inclined, if you will, because sometimes we just do this internally to be able to make sure that we're reducing the impacts of the products that we're designing. Sometimes we take this back to the client and say, hey, here are the impacts, here's the baseline. And here are some ways to reduce those impacts. Would you like us to pursue them? And then often we are sometimes limited by what they think they can do. So we may not reduce all of those impacts that we were hoping to reduce, but only do one or two things.
Yeah, it often depends on how technically competent and also technically engaged they are with us on our project. We have some that it's a business stakeholder and they know what they want and they tell us the product they want and then they let us go and make it for them and deliver it to them at the end. Other times it's a bunch of engineers who really want to be involved every step of the way, and we'll run a like mini brainstorm ourselves first so we're prepared, but then we would work collaboratively with them. We'd literally bring them into the room or onto a Zoom call and run through the process with them. So yeah, we've done that a few times as well.
And my last question is, how do you actually help your clients centralize their sustainability data?
Yeah, this is a tricky question. So in recent conversations, what we've noticed on a recent project, actually, what we noticed is they often have a patchwork of systems. So they have one system that they rely on to send requests to suppliers and collect supplier data. And not all that data comes through that system. Sometimes suppliers send them an email with a PDF. So there's a lot of different data sources like that. And then they have a completely distinct PLM that keeps track of their bombs. And then they have another distinct LCA system that they use to run the LCAs. And these pieces are often not connected. And then what that means is a lot of data entry and manual compilation of data. So there is a team, now that we're part of the larger Capgemini ecosystem, there are teams that specialize in building what they call a sustainability data hub, which then builds these pipelines between the existing client systems and then connects them into an LCA tool to run the assessment. There have also been cases where they have built an LCA system from scratch that then is tailored to the data sources, to the templates that the data comes in, and then run the assessment. Sometimes they use off-the-shelf products like, say, MakerSite to then run those assessments. So we've seen both cases where it's either off-the-shelf LCA or some sort of custom solution.
Awesome. Thank you very much. This has been really, really enlightening. I really appreciate both of you, your time, and all of the information you've shared. It's been very interesting and enlightening, and I'm sure our team also agrees. So I thank you very much.